Graphing quadratics in 3 different forms. All right, so this is vertex form, and vertex allows us to find the vertex very easily. So we find the vertex by asking the question, what number can we plug into x that if we added 3 would equal 0? -3. It's always the opposite. The y value of our vertex is our k, which is in the back. And so now we can graph that point. -3, -4. There's our vertex. It's also asking us which way this graph opens. Keep in mind that what determines that is the a value. And in this particular problem, it's an invisible 1. That's right here. It's positive, so it opens up. That means my graph is going to look something like that, an upwards U. It then asks for the axis of symmetry. Keep in mind that the axis of symmetry and the vertex are on top of each other. The axis of symmetry is an invisible line that we will represent with this dashed one that goes straight through the vertex. Those two things, vertex and axis of symmetry, are in the middle of the graph. So we write our axis of symmetry as an equation. It's going to be x equals, because it's a vertical line, a line that goes up and down, and it went through the number -3. Keep in mind that the axis of symmetry value and the vertex, the x value of the vertex, are always the same number because they're on top of each other. All right, we need 3 points to graph a parabola. Okay, we only have one. What we're going to do, we're going to find the y-intercept, and that's going to help us graph this parabola. So every single point on the y-axis, like 0, 9, 0, 7, 0, 5. These are all points on the y-axis. They all have a 0 for the x. So a y-intercept shows up on the y-axis, which means that the x value for a y-intercept is always going to be 0. But if I know what the x is, I can always find the y by plugging it into the equation. Since the equation equals y, if I plug a 0 into here and do the math, it's going to tell me what y is. So I have y equals, I'm going to replace the x with a 0, so I'm going to find the y-intercept. 0 plus 3 is 3. 3 squared is 9. 9 minus 4 is 5. So now I have my y-intercept. So I'm going to plot that point. Like I said earlier, I need 3 points. So to figure out the third point, I'm going to use my axis of symmetry. Once again, the axis of symmetry is in the middle of the graph. So if I have a point that's 1, 2, 3 to the right, there's another point 1, 2, 3 to the left. Now that I have my 3 points, I can graph my parabola. All right, this one is vertex form. Vertex form is the one with the 2 parentheses. The first thing it's asking us to state is how this graph opens. Looking at the front, I can see I have a +2. Therefore, it opens up. This is going to be a graph that opens up like this, like a nice U. All right. It then wants x-intercepts. Factor form lets us find x-intercepts really, really easily. We do that by looking at the x's. And I ask the age-old question, what number -2 would equal 0? +2. I do the same thing here. What number -6 equals 0? +6. So I have 2, I have 6. Now keep in mind that I have these 2 points. I need 3 points, so I do need to find the vertex. But to do that, I'm going to find the axis of symmetry first. And as I mentioned before, the axis of symmetry is always in the middle of the graph. So if I have these 2 points, I want to know what number is in the middle. So I can count inwards 1, 2, 1, 2. So right here is where my axis of symmetry is. It is at x equals 4. Now, sometimes it's kind of hard to count to figure out where it is, especially if the points are really far apart, or if you have an odd distance between the 2 points. then you would have a decimal for your axis of symmetry. This is what you can do if you ever want to find that value without having to physically count it on a graph. You take your two x-intercepts, the 2 and the 6 in this case, you're going to add them together, and then you're going to divide by 2. You're going to find the average, and the average is going to find the value in the middle, and that is algebraically how you can find that axis of symmetry, okay? Now that I have the axis of symmetry, I know that we have a vertex on that dashed line somewhere. I don't know where it is on the dashed line. I just know it's on that dashed line. Therefore, I will know that the x part of my vertex is 4. Once again, this number here and the x part of the vertex are always going to be the same number because they're on top of each other. Now, if I want the vertex, I know it's x. I know the x right here is positive 4. So if I plug it into the equation, it would tell me the y. So I'm going to go y equals 2 parentheses. I'm going to plug the 4 in, minus 2. Plug the 4 in, minus 6. And I'm just going to do the math. You could type this into a calculator if you wanted to. 4 take away 2 is 2. 4 minus 6 is negative 2. 2 times 2 is 4. And negative 2 there. So 4 times negative 2 is negative 8, comma, negative 8. So now my point is at positive 4, negative 8. And now I have my 3 lines, my 3 points, so now I can graph my parabola. And that's factored form. All right, our last form is standard form. First thing standard form is asking us to do is determine how it opens. This time we can see our A value is in the front, is a negative number, which means this graph is going to open down. So my graph should look something like that. It should be upside down. The next thing I need is my y-intercept. Well, if you remember from our little chart that I had you write down in class, this number right here, the negative 3, is the A value, negative 6 is the B value, and positive 9 is the C value. And the C value is the y-intercept in standard form. So this would be 0, 9. Now you might ask, like, how do you know that? Why is it? Why is that a fact? Well, let's think logically for a moment. If my x for a y-intercept is always 0 because it's on the y-axis, if I replace all the x's with zeros, well, 0 squared is 0. 0 times negative 3 is 0. Negative 6 times 0 is 0. And then I have my plus 9. Well, 0 plus 0 plus 9 is 9. That's why that's a 9. And since that's always going to happen, the first two terms here and here are always going to turn into zeros. The C value, the constant, will always end up being the thing left over, which would be the y value for our y-intercept. All right, so now that we have that, we have to figure out the axis of symmetry. So let's plot this y-intercept and see what this tells us. So I plot it here. That one point doesn't help me. The axis of symmetry always goes through the vertex. This is the y-intercept, so I'm going to have to think of a different way to find the axis of symmetry. So if I know that the axis of symmetry is going to be x equals something, and I know that the vertex, its x value, is the same number, I could actually find the vertex first, and then I would find both. So we're going to go back to the Algebra 1 days where you were told a formula. It was called x equals negative b over 2a. This lets you find the x part of the vertex. Therefore, it would also let you find the axis of symmetry. So our negative b is in the formula. You can see up here in the equation, our b is a negative 6. So a negative 6 over 2 times our a is a negative 3. And so we can just do the math. A negative times a negative turns to positive. So we end up with positive 6 over 2 times negative 3 is negative 6. 6 divided by negative 6 is negative 1. So now we know that these two values are at negative 1. So my axis of symmetry is actually at negative 1. Well, I need to figure out what is the y part of the vertex so I'm able to graph the point. All right, so I'm going to take the negative 1 I got for the x value, and I'm going to plug it into the equation y equals negative 3x squared minus 6x plus 9. I'm going to plug it into there, and I'm going to find out what the y value is. So y equals negative 3, parentheses, all the x's are going to turn into negative 1s because I'm plugging this in, trying to find the y value. And then you could use your calculator to type this in. Just be careful how you type it in. I'm going to do it by hand. So negative 1 squared is positive 1. Negative 6 times negative 1 is positive 6. Negative 3 times 1 is negative 3. Negative 3 plus 6 is positive 3. And then 3 plus 9 is 12. And so that is going to be the y part of our vertex. And so that point is right up here. All right, we're almost done. We need one more point, and once again, we can use our axis of symmetry to help us find it. We can see that the y-intercept is 1 unit to the right of the axis of symmetry, so there's another point 1 unit to the left. And that's graphing parabolas in their 3 different forms: vertex form, factored form, and standard form.